Hey guys, it's your favorite math teacher here. I'm just gonna go over 2-1. This is your video to go along with your notes. So you'll see me leave this area to go fill out the notes. All right, so this is section 2-1, solving one-step equations. So just some definition stuff here to start. If I can get all this to work. And you guys will have to, I know you always hear me say bear with me, but the scroll bar on this thing doesn't work real great, so you'll see me struggle with that a little bit, so be patient on that. But it says the blank of an equation, so that would be solution or solutions. So I'm going to write SOLUTION. So usually just solution. We can have equations that have multiple solutions, so or solutions of an equation are the value or values for the variable that make the equation that would be true. And then it says blank are equations that have the blank. So equivalent equations is what we're looking for there. Equivalent equations are equations that have the same solution. So as we get into more complex solutions, multi-step equations and stuff, you'll see us write out several different equivalent equations as we go to isolate the variable. So that's the big thing we want to do. We want to isolate the variable. You guys know this from 8th grade using inverse operations. So looking at A, it's x plus 27 equals 13. From lesson 1-8, we know that means what number plus 27 equals 13. Algebraically, all we need to do is undo plus 27. So that would be minus 27 minus 27. And then what I do to one side, I have to do to both. If I can get my pen to work here. Minus 27. When I say sides, I'm talking about sides of the equal sign. You'll see some math teachers draw like a divider down the middle. I don't usually do that, but that's what I mean when I say sides. And that gives me x by itself over there. And that equals whatever 13 minus 27 is, right? And there's where you're just going to use your calculator. Do 13, take away 27. And so we get negative 14. So let your calculator help you with the computational part of the problem. And then again, it's always good to remember, like, you can plug that back in just to see if it works. Double check your work, right? So if we go back to the original, what we're saying is that negative 14 plus 27 is 13. So I can just double check that real quick. Negative 14 plus 27, and that does equal 13, so I know I'm good to go. Okay, looking at example B, I want to isolate B, so what's with B? Minus 3, so to undo minus 3, I'm going to do plus 3 to both sides. Plus 3 to both sides. I'm going to get rid of that, leave B by itself. And then, so whatever negative 7 plus 3 is, will be our solution for B. So negative 7 plus 3 is negative 4. So there you go. So negative 4 is equal to B. All right, I'm going to leave the rest for you on this one, and you can find the solutions to C, D, and E on the filled out notes. All right, example 2, solving equations with multiplication and division. So one that looks like A is we would call 4 the coefficient of x, okay? So that means 4 times x, right? So same principles apply here. So how do we undo 4 times or times 4? You're going to divide by 4. What I do to one side, I must do to the other, or I don't have an equivalent equation if I don't do that to both sides. So that gives me 1x on the left side, which we just write as x. And then let our calculator do the computational part for us. So negative 6.4 divided by 4. And that's going to be negative 1.6. Negative 1. And if I plug that in, it should work. 4 times negative 1.6 should be negative 1.4. All right, looking at the next one, B says negative 9 is equal to x over 4. Okay, so x over 4, what's that mean? That means x divided by 4. So the inverse operation of divided by 4 is times 4. I like to show that. I like to show times 4. You can show it with a dot. I like to use parentheses there. I like parentheses 4, just means times 4. And same way over here, so parentheses 4. So I'm multiplying each side by 4. And my purpose for doing that was to get rid of divided by 4. All right, so x over 4 times 4 is 1x. On the other side, we have 4 times negative 9. That is negative 36. That's equal to x. Okay, and again, just mental math. Does my answer make sense? If I plug in negative 36, or if I substitute negative 36 right there, negative 36 over 4 looks like negative 9, so that's going to make sense. All right, so I'll leave C, D, and E for you to check on the notes. Going to example 3. So people kind of tend to have a little more trouble with these. And the more fractions we have, the more trouble kids tend to have. But same principles are going to apply here. So I'm going to show you a couple different ways to think about this. And I think personally, one way is a lot easier than the other, but just kind of stay with me here. So if we just stuck with the same principles that we've been doing, we say, okay, our coefficient is 4/5, right? Well, one easy way to deal with that would just be to change 4/5 to 0.8. So you could do that. Another way to handle it would just be to say divide by my coefficient, right? So if I divide both sides by 4/5, now that seems a little weird because when you get into dividing by a fraction, it's a little more counterintuitive. But we know it's going to undo times 4/5 and give me A by itself. And now we're going to use our calculator, right? So what's 28 divided by 4/5? 28 divided by, now you guys have a TI-30. What you're looking at on my screen is a TI-84. It doesn't have the ABC button, so yours is actually going to be easier to punch in. For me, to type in a fraction, I have to do parentheses and then 4 divided by 5. You guys don't need the parentheses on yours. You can just do 4 ABC 5. And that's going to give you whatever it is. So in this case, it's 35. Now, this is an example of one that's not so easy to tell if you're correct, right? So maybe, you want to double check your answer, right? So what's 4/5 times 35? 4/5 times 35. Just double checking my answer, and I do get 28. So now I can feel good about my answer. Okay. So another way to think about this, and this is the way it's more traditionally taught, is well, think about like what, it's been a while, but what does it mean to divide by a fraction, right? So I want you here to kind of remember or recall that something like 1/2 divided by 3/4. How would we do that if it were on the DMR? We would do same, change, flip. Hopefully you remember that. So that's the same as 1/2 times 4/3, right? I'm not going to work that out. That's not the point of this, but we can use same, change, flip to divide by a fraction, right? So the other way to think about this, we're doing the same thing, just showing it a different way, would be to divide by -3/4. Look at example B. I'm actually going to multiply by -4/3. So I'm kind of showing you two different approaches to do the same thing. I like to think of it this way, probably just because that's the way I was taught. But you can kind of do your own thing there. So that's going to give me 1B on the right side. So I'm going to go ahead and write B. That's the easy part. And then I'm going to use my calculator on the other side. So 12 times -4/3. 12 times -4/3 is going to be -16. Let it pop up here. -16. Maybe it'll pop up. There we go. And the good thing about equations is you can always check that answer, right? So if we substitute -16 right there, let's just see what happens. So if you do negative, so -3/4 times -16, I do get +12. So now I can feel really good about my answer. Okay, the last thing I want to say about this, and I could have mentioned this in the previous examples, but last thing I want to say is, and I'm not going to work out D, but I want you to know that another kind of side note here, good thing to know, that 3/5 times D can also be written, or is equal to 3D/5, right? So if you thought about it that way, you would multiply by 5 to get rid of divided by 5. You would divide by 3. So really just multiplying by 5/3. I think we have a word problem, and that will be it. So unfortunately, it's a little bit cut off on the screen, so I'll just kind of read it, and you'll be able to see it on the notes. So it says that toucans and blue and yellow macaws are both tropical birds. The length of an average toucan is about 2/3 the length of an average blue and yellow macaw. Toucans are 24 inches long. What's the length of the macaw? Okay, so on a story problem, when you are trying to write an equation, it's a really important step to define your variable. So what are we trying to find? I always tell my students to look right before the equal sign, right? So it wants to know the length of a blue and yellow macaw. So we can just say, we can let L stand for that, or X, or whatever. Letter is not important, but we're going to say L means L equals the length of macaw. Hopefully that pops up. There we go. Okay, so I've defined my variable. That makes life a lot easier. All right, so just to recall, it said that the length, so let me reread this. The length of an average toucan is about 2/3 the length of a macaw. So do we know the length of the toucan? Yes, the length of the toucan is 24 inches, right? And we say, and it says that is about 2/3 the length of the macaw, or 2/3 of L, and then we just want to solve that, right? So I am dividing by 2/3 on both sides, also known as multiplying by 3/2 on both sides. So 24 times 3/2 is 36. And remember, you can just use your calculator to get that number. So 36 equals L. On a word problem, you always want to finalize there. Remember, that's 36 inches. So our final answer would be 36 inches. Always good to say, does my answer make sense, right? So if the length of a toucan is 2/3 the length of a macaw, it would make sense that the macaw would have a bigger number than 24, so 36 kind of makes sense that way. All right, so for the ones I didn't fill out, again, you can just view the filled out notes. Hopefully this video is helpful as you work through your assignment for lesson 2-1. And thanks for your time. Good luck working through your assignment. Thank you.